Unit 1, Lesson 3, Factoring Part 2. So today we're just going to look at a few other factoring methods, as well as some special things to look out for when you are factoring. So the next method we'll explore is called factor by grouping. Basically, you only use factor by grouping when you've exhausted all the other three methods. So you check, can I common factor anything? No. Can I use my decomposition or magic numbers method? No. Difference of squares? Nope. So you think, okay, I'm going to see if factor by grouping works. And factor by grouping also is used when there's four terms. And the way you do this is you common factor the first two terms together, and then you common factor the second two. So it's kind of like the middle step of decomposition. Let's scan this. Is there anything that I can common factor first? And there's nothing common between each of the four terms. So I'm going to use factor by grouping. So let's go ahead. Let's common factor these two together and then those two together. 4xy plus 32x. Both of those can be divided by 4. And there's an x in both terms. So my common factor here is 4x, and then what's left in the first term when we divide it by 4x, we're left with just y, and in our second term, we're left with just 8. What's common between negative y and negative 8? Not a whole lot. We can really only just divide them both by negative 1, so my common factor here is a negative 1, okay, and then write what's left in the bracket. So, or think, divide each term by negative 1. So negative y divided by negative 1 is just y, and negative 8 divided by negative 1 is positive 8. And now it's exactly like that middle part of decomposition. So because our brackets have the same thing inside of them, and then whatever's left over is outside of the brackets, let's form our two factors by taking what's left over. So the 4x and the minus 1, put them together in one set of brackets. Then your second set of brackets is your y plus 8. Okay, and then we factored it. Okay, our second example here looks kind of crazy, and some of you might be tempted to use the distributive property to expand this first, then collect like terms, and then trying to factor it. If you take that route, it's going to be very difficult. So I want to show you something that you should try and recognize to help you solve a question a little bit more efficiently. And to do this, I've asked you this little question above. So without looking at part B, let's just look at this example here. So that expression I just wrote down, that polynomial, how would you factor that? Okay, hopefully you look at it and say, okay, common factor something. I can factor out that y, because each term has a y. So I'm just going to factor out that y. Put it out in front. What's left over goes inside of the brackets. The reason why I want you to think about that before addressing part B is because if you look, part B is the same question as this one, except I've replaced each of the y's. Instead of writing y, I wrote x minus 5. Okay, so approach it the same way. What's common in each of those terms? This term has an x minus 5. This term has an x minus 5, and this term has an x minus 5. So let's go ahead, factor out an x minus 5 from each of the three terms. What's left over? We have a 7x squared minus 11x minus 6. Okay, so recognizing that makes factoring the rest of this very easy, because now we have a trinomial. So let's use our decomposition method, or magic numbers method. Okay, so I need two numbers that multiply together to get the product of a and c, so negative 42. Those same two numbers have to add together to get negative 11. So what are the two numbers? Okay, it's negative 3 and 14. Now we replace that middle term with those magic numbers. So instead of writing negative 11x, I'm going to write negative 3x and 14x. Now we common factor the first two terms and common factor the last two terms. Okay, so between the first two terms, the only thing common is the x, and the common factor between the next two terms is just 2. Okay, now let's write our factors down. So let's take the common factors from both, put those into a set of brackets, and then our second set of brackets is the 7x minus 3. Okay, and now part B is factored completely. So that's something to watch out for. Okay, a couple more things I just want you guys to watch out for on tests. So part A, if you were to look at this question, it might be tough to think about how you'd factor it first, because it's not a difference of squares, right? You can't take the square root of 18 and you can't take the square root of 50. But if you were to common factor this first, if you notice that, hey, I can divide each of these terms by 2. So let me do that. Factor out a 2. This turns into 9x squared minus 25. Now look at that. We have a difference of squares. So by doing common factoring first, sometimes difference of squares arises. Okay, so now we can factor this really easily, right? To factor differences of squares, you set up your brackets, take the square root of the first term, write it first, square root of the second term, write it second, and then put a plus in one and a minus in the other. And then this is factored. All right, let's try this one here. What's common in between both of those guys right away? We can factor out an x. So then we're left with 16x to the power of 4 minus 2,401. Now you're going to notice that that is a difference of squares. Okay, so let's do this. Let's set up our brackets. Okay, take the square root of this, put it first in both of the brackets. So the square root of 16x to the power of 4, 4x squared. Okay, now take the square root of this, put him second in both of the brackets. So the square root of 2,401 is 49. And then we put a plus in one and a minus in the other. Now the special case that I want you to be aware of here is we are not finished. Yes, we've used common factoring, and yes, we've used difference of squares. But always, always, always when you're done, ask yourself, can I factor this further? Because look at this. There's another difference of squares. So this question shows you that sometimes a double difference of squares happens. Okay, so let's use difference of squares on that second set of brackets to factor it even further. Okay, this is not a difference of squares because they're separated by addition. But this one is. So what's the square root of 4x squared? 2x. So write that first in both of the brackets. Then what's the square root of 49? It's 7. So write it second in both of the brackets. And finally, put an addition in one, subtraction in the other. Okay, so double difference of squares can happen. Now we're done because there's nothing else that we can do to factor this further. Okay, let's look at part C. So the reason why I wanted to do this as a special case is because when you look at this, you might think, oh, I can't use the magic number decomposition method on this because it has an x4, an x squared, and then no variable. And we're used to using decomposition on quadratic. Okay, but I'm here to show you that you can still use it on something like this. Okay, because really, the decomposition method is really only concerned with the coefficients, not so much the variables. Let's approach as normal. We need two numbers that multiply together to get a product of A times C. So 1 times 30, just 30. And those same two numbers have to add up to get your B value, which is negative 13. What are the two numbers? Okay, the two numbers are negative 3 and negative 10. Okay, now some of you might be thinking, well, A is 1, so can't I just do this? Use my magic numbers as the factors. And you can if you can understand one thing. So that rule worked when we were working with quadratics. Okay, so that method worked for both these situations, but because this question is not a quadratic, there's just one little thing we need to understand in order to make this correct at the end. Okay, so we have an example here, and we'd factor this, right? We know that the two numbers that multiply together to get negative 2 and add together to get 1 are going to be positive 2 and negative 1. Okay, and we would just write them quickly as the factors, and that's what we tried to do here. But here's what we need to realize, and we've never really explained it before. Okay, but how are we getting this x value? And where we're getting it from, it's the square root of that first term. And that's why we could just write x very quickly. So as long as you understand that, you would realize that, okay, this is the square root of this. So because it's x to the power of 4, the square root of that is no longer just x. Square root of x to the power of 4 is x squared. Okay, so that is the final answer. If you don't understand that process, okay, you would just treat this as decomposition. Okay, so after you come up with your magic numbers, replace that b term with your magic numbers. Okay, and then let's factor by grouping. So let's common factor the first two terms, and then let's common factor the second two terms. Okay, and then let's develop our factors. So the x squared and the minus 10 become our first set, and the x squared and the minus 3 become our second set. Okay, so same idea there. So this is just showing you that it is possible to do this sort of thing when you're not working with a quadratic. Okay, here we're working with a degree 4 polynomial. Okay, let's try it again. So, again, we have a trinomial, so let's try decomposition. So we need two numbers that multiply together to get negative 42, and those same two numbers add together to get positive 1. What are the two numbers? They're negative 6 and positive 7. So let's go ahead, because A is not 1, let's replace our B term with our magic numbers. Okay. So you can see that this is exactly the same as what we would do if it was a quadratic, just we're working with higher exponents. Now let's common factor the first two terms. So we can factor out a 2x5 from both. So we're left with x to the power of 5 and negative 3. And then let's common factor the second two terms. So we can common factor out a 7. Okay, and now these turned out the same, so let's go ahead and finish simplifying this. So the two common factors we join together in our first set of brackets, and then the x to the power of 5 minus 3 is our second set of brackets. Okay, so if you can wrap your head around this, you're going to be very comfortable factoring any type of expression, no matter what the exponents are. Okay, again, if this is tough, this is review of grade 10, so please, please, please see me and we will work through this together.